In this video, we will look at calculating compound interest when we know the number of compounds we have in a year. Compound interest is simply when we earn interest on our interest. In the case of compound interest, where we know the number of compounds or payments we get in a year, we use this equation, a equals p times 1 plus r over n, to the nt to calculate the number of compounds. A represents the final amount in the account. P stands for principal, which is the fancy bank word for the starting amount in the account. R stands for the rate at which you earn interest, which is always written as a decimal. N represents the number of compounds. Or how many times per year the bank will pay interest into the account. Finally, T stands for the amount of time in years that the investment is left to be. Let's take a look at using this formula with some situations involving investments. Recalling that our formula is A equals P times 1 plus r over n to the nt, we're going to invest $13,000. This is our principal or starting investment. 8% is the rate, which must be written as a decimal, 0.08. It is compounded monthly, meaning the number of compounds in a year is 12, because there's 12 months in a year. And we want to know how much is left after 9 years. This is our time, and so our equation becomes P, or 13,000, times 1 plus r, which is 0.08, over n, which is 12, to the nt, which is 12 times 9. It's very important, as you enter this into your calculator, you're careful with the order of operations. You may have to put the 12 times 9 in parentheses as part of the exponent. Some calculators may require you to do only one step at a time. Be careful that you know how to use your calculator to evaluate this amount. As you do, it is important we use as many decimals as possible to ensure accuracy. Let's go ahead and do the exponents in the parentheses in one step. A equals 13,000 times, when we use my calculator, we get 1.006667 to the 108 power. Depending on the calculator you have, you might be able to multiply all that out in one step, telling us the amount in this account is $26,644.85. Let's do another example where we use this compound interest formula. The amount is equal to the principal times 1 plus the rate divided by the number of compounds to the nt. Here, the principal, or starting amount, is 800, times 1 plus the rate, which is 3%, written 0.03, over n, which is the number of compounds, and there are 4 quarters in a year, to the nt, or 4 times 5 years. Again, I'll have my calculator do the exponent in the parentheses first, giving me 800 times 1.0075 to the 20th. Now, depending on the calculator I have, I might be able to do the rest in one step, telling me the amount in this account after 5 years will be $928.95. Being careful to use your calculator correctly, the compound interest formula can quickly calculate the final balance.